Hello. Today I'm going to demonstrate how to do integration for this type of the integral. Let's go to the whiteboard. In general, you will encounter various integrals associated with sine and cosine functions, right? And one of them will be like just this one. So this one, I will equal to integral sine x to the power of n dx. Now this is the general form of this integral, and this integral can be subdivided into two categories. One is when n is odd, so n is odd, so n equal to say equal to 2k plus 1. Another is n is even, n equal to 2k. So you can rewrite this as, for example, I put n here, just indicate how to denote this integral. They put n here. So therefore, we have, in this case, we can write n1. n1 is one of them. n1 will equal to sine x dx, okay? And similarly, I3 will equal to sine q x dx. And this I5 will equal to sine to the power of 5 x dx, and so on. Generally speaking, if n is an odd number, the solution is relatively simple. If I just perhaps we will talk about that afterward. We'll talk about this case afterward. So if that is the case, we can, for example, when n equal to 1, so we basically can use our simple formulas in calculus. So what we do, I would often suggest people do that way, so actually we can put the sign behind the d. And then in this way, we will got the d cosine, so cosine x, and apart from the negative sign here. And that will allow us to cancel the two operations, namely integration and differentiation. So the answer would be straightforward. So you got negative cosine x plus a constant. Now the trick to solve the I3 is that to separate. We can separate. We can borrow the sign here. We can borrow a sine theta here. We can rewrite that as sine square, and then sine x squared times sine x dx. Okay, we use the same trick as we used before. See, when you see this part, so you will see that I can put this sign back to that one. So that's the trick I used here. So in this way, we can rewrite this integral into this form, and that is equal to sine square x d cosine x, d cosine x, d cosine x. And apart from the negative sign here. Next is just using the Pythagoras Theorem to rewrite sine square in terms of cosine x. So that integral will become two parts. One is 1 minus cosine square x and d cosine x. So the rest is simple. So the rest of them is simple. So basically that if you wish, you can continue. That would be d cosine. So that would be d cosine theta minus negative, negative become positive. That became cosine. I use the new variable here, the du, where u equal to cosine theta. So the rest is rather simple. I will stop here. So basically, you can cancel this two operation. So it is relatively simple so far. Similarly, we can treat this I5 again in a similar fashion. We can rewrite sine 5 as sine x to the power 4 times the sine. In this case, I just jump a little bit. I just go to the d cosine x, all right? So they are, they just, you can arrange that sine 4 in terms of the, say, the cosine, for example. You can write it as 1 minus cosine x square and d cosine x. So it's rather simple. Now here I would like to use the notation I often use during to deal with this type of question when integration or any algebra equation involve frequently or especially when you're dealing with trigonometry functions, exclusively involve sine and cosine. You can introduce this symbol. So S where can be represented sine x, and C will represent cosine x. Okay, so bear in mind that d sine, when you say the d sine will equal to the cosine. And just rewrite this part a little bit crowded here. Wait, if I could, yeah. Okay, good, cool. So basically, this is a notation I often use. S will represent sine x. Bear in mind as a ds will equal to cosine x. So when I have to cosine, I just write to make sure it's cosine x and dx. Okay. Similarly, I would like to simply use a c to represent a cosine. Of course, if the expression involve other trigonometry function, and you must be careful. It's just because C could also represent a different trigonometry function because a cosecant. That it would be cosine x. Bear in mind, dc will equal to negative sine dx. Okay, so that's the notation I often use. I hope you will try. If you found this useful, you are welcome to use this notation here. Okay, if I use this notation, then the expressions involved will become much simpler. So that is a reason behind. So for example, if we continue do that using this notation, we will have that we got two terms. We got the dc, okay, plus, before that we have to expand that term inside. So we have expand that. We're equal to, so that we're equal to use basic algebra formula that would be 1 square minus 2 cosine square x plus cosine x to the power 4 and d cosine x. Okay, and use this notation, we can simplify that as if the first term is just integration dc. Okay, second term will be 2, that would be c squared and dc. And third term will be plus c4, c to the power 4, dc. Okay, so again, it's just rather simple. You can use the basic formula into integral, namely that if you have integration of x n dx. And that was simply divided by n plus 1. And you raise the number by 1, so it's n plus 1. Okay, so I don't want to go that far. And if you have time, you can finish this integral. So basically, as a whole, if n is odd number, it is a relatively easy or straightforward. When I mean straightforward, you don't have to invoke in too complicated substitution, or you don't have considered the integration by part. So integration by part is a weapon. It's like cannon. You wouldn't use cannon all the time. If you use cannon to kill the bird, you destroy everything. You destroy the house. You destroy people living in the house. You see. So be careful when you choose your weaponry. When you choose your weapon inventories, of course. Now, this just now focus on the second type of the integral, namely when the integral is even number. Okay, I just write a few example here to illustrate these circumstances. In this case, we will encounter even number. One is the sine square x dx. You say, well, it's not so easy. It's not so difficult, because when we have this one, we can always go to the trigonometry relation to go to the double or half angle formula. Here we just use it as a sum as 1. I think it's plus minus. Double check that. Yeah, that is minus cosine 2x dx. Okay, I will stop here. And but things can be a little bit complicated. If you go to a higher, you go to larger even number. So next will be the 4 dx. I will talk about this later. And also things can become very nasty. Okay, if the numbers go beyond 6, you can go to even 8. Okay. So today we are focused on how to eventually solve this problem. So when the n is an even number, how to solve this integral, right? To solve this problem, let's go to the new page. So we have to, first of all, have to solve some of the relevant, relatively simpler case. For example, this one. So this is also our objective. So let's go to next page to discuss this related integral one by one from the n equal to 2. Let's go to next page. So first we just consider this integral. So how about I2, namely the sine x squared. Okay, we have mentioned that. I just repeated that because we are going to borrow this result to solve the more complicated integral dx. I just repeat what we did before. So when you see the sine square, so we were simply we can get rid of this square by using the trigonometry function. I will just write it quickly. That is half 1 minus cosine 2x. Okay, so in this way we have successfully reduced. We can get rid of that the square, because you will see it's relatively easy if we just deal with cosine, compare with cosine squared. That have to be this variable is x here. Can we just finish this integral, although it is not so difficult? So the first term will be integral dx divided by 2. Of course, you can put a 2 outside. And second term we just jump to the, we just write it 4 here. I tell you why this 4. Because I'm going to rewrite this integral cosine 2x as u du, where u is equal to 2x. So that's why there's additional 2 to be divided in order to keep the balance, in order to make this equal sign valid. Of course, and the result, just write the result. So the result is rather simple. So basically that will give us the I2. Can we just write, yeah, we just write I2 here. I2 will equal to, say, half x, and plus, and that is cosine. That's easy. Cosine is just sine. So the integration is cosine just sine. So you got 1 over, so that you got a cosine, sine. You go to sine 2x divided by 4. Apart from constant, okay, sometimes you have to edit constant because some IB examiner are very strict. So you have to, if you miss out this constant, you lost 1 or 2 mark, which is not with nuisance. Okay. Let's jump to the second one. The second integral is that the even number is 4. Notice the notation. Here we use a consistent notation because this number is equal to this number. Of course, when you actually solve the problem, and you don't have to use this consistency, because sometimes it's quicker just increase this number of subscript whenever you see a new integral. Okay, I will talk about that in detail later on. So first, we just consider this this example. Now, how to solve this question? How to solve this integral? As I can see, so the D4, well, one way, because things have to go that far, we can either use this algebra method here. Can we see, did we notice how we solve this these equations? So this is a sine, cosine. Oh, it's not different, it's different. Here we are, I think, we are obliged to use our canon, namely integration by part. That is a weapon. That's integration by parts, or just called IBP. Okay. How do we do that? So what I can do is that we just have to assume that we have to, the first step is to select what is u and v, the new variable. So I just for my customers, I just say, because this power is too high, I want to reduce the power here. So therefore, I call this u, because once you use integration by part, this term or u is to be differentiated. In other words, this power will be reduced by 1. Then, therefore, I will call this one as v. Okay. So in doing so, we can just rewrite this integral as u times v. Sorry, u times dv, rather, u times dv. So recall the integration by part, so that we can be rewritten as u times v minus v differentiate du, v du. So what is du here? There's something I have to put some explanation here. So basically, the u will equal to sine x to the power of 4. Therefore, so du will equal to 4 sine x 3. Can you see? The power reduced by 1. But be careful, you have to use the chain. You have the chain rule here, using the chain rule. Chain rule is dealing with the composite function here. So after doing differential, do the power function, you have applied this chain rule to dealing with differentiation of sine x. That will give a cosine x. Can you see that? And also have the dx, So we are going to, what can we do? We are going to use our notation now to simplify this one. So we just see it's called 4sq times c and dx. So if you substitute that into our equation, we got u times v. So u times v minus v. V is what? V is x. You see, which is x, right? Oh. So v is x. Let me see. For the dx, v u dv, v is x. So what we have here is that if we substitute v here, where is the v? So this du, v will be equal to x, There's something I don't want. Then I got times 4 sq c and dx. Is that right? We have to be careful now. How do we manage to solve this one? CQ times C. Let me see. Differentiation by part. This is Q times C. No. Yeah, probably something wrong. We can't go that far because here we got the X is the one unwanted. So this X is unwanted because that will make the situation more complicated. Is how to find that one. C squared times C. Ah, yes. Before that, okay. So this is there's no throughway. No throughway, so we have to do it again. This time, be careful. I changed my strategy simply smartly. So therefore, I will rewrite, I will borrow this 1x. Okay, I'll do that way. Before I do using the integration by part, I will just rewrite the sign as 3 plus 1. Use the index null. It is one of index null here. So that becomes q. You think that becomes sine q, because q is well known. We know how to deal with q. So then we put sine x here, dx. As I say, I will prepare this one. I will just trying to put the sign behind the d. So what can we do? We can, in this case, we can rewrite it as we just write it. Can we write this one? That would become SQ times negative sign, DC, C for cosine. Okay, then we will use the integration by part. Good, that's fine. So here I will call this is our U, and C is our V, okay? Using the formula integration by part, what we have, can we just go up here? Can we just go up here? That will give us negative SQ sine Q times cosine minus VDU. Yeah, that's VDU. Here we use this. Here we use the application by part, integration by parts. Now, the first term, if we just keep the first term, it's simple. So SQ times C. Negative times negative become positive. It becomes positive. Now, what is the V? V here is not X anymore. V is our C. Can say V is C. So we got the C, everything inside integral. How about du? Now, du, where instead of doing the integration of the to the power of 4, this time what we need to do, so we don't need this one. So we use the same, we use the argument here that if in this case, u equal to sine qx. So therefore, if we want to find the integration, differentiation u, you have to use this formula, 3 sine. So we have the sine, so 3 minus 1 became square. So sine 3 times sine square. And then don't forget the chain rule. You have to use the chain rule. In what then the chain rule will give you positive cosine, and then dx. Okay, dx. So this is a equation we're going to use. That will be time. We put the c, we times c s square times c and dx. Okay, that's cool. So then we got the sq. We got sq c plus, we put the number outside the integral because it's constant. So we put the 3 here. The number is important. So what happened inside? So where you have, we have the s square times the c square, okay, dx. Now, because we are dealing with the sine function, so whenever we say cosine function, we can always use Pythagoras Theorem to rewrite this formula in order to use the s as explicit variable. Of course, it's complex function of x as well. So we just copy that once. So that is, okay, not once, 3 times. So that's why you see the benefit use s to represent the sine and c to represent the cosine is here, is indicated in this example, exemplifying this example. Okay, so you don't, this is the copying is easier, and the chance to make a mistake is diminished. Let's continue. So that would be plus. Now 3 outside is constant. So what's inside? What's integral? Then we have to use the Pythagoras theorem. So that we I just write it directly. So s squared plus, minus s4 to the power 4. You see. So this is something very interesting. So here we will see that power. We will see that there is a chance to rewrite this formula in terms of the integral we are looking for. Okay, so this is one of the first linear equation. Is algebraic relation between. So we'll just continue over here. So that's one. We just, if you forgot what I'm doing, okay, if we have forgot what I'm doing, so basically we have that we have I4. So I4 can be written as this integral. This the sum. So have 3 terms. They got the first term is SQ times C. The second term is can we say is a 3? Can this is S2? Okay, so that can be just use the notation for integral. That's the power of 2. See, here we borrow this because the reason I rewrite this term because we can use the result here directly. We don't have to, when we're dealing with more complicated issue, we can always use this power directly. But of course, if this question is given in the exam, you probably just starting from the highest power and using integration by parts and use various notation. But here, because I want to explain that the methods I used here can solve any form, any power, any n, okay, especially any even number, such as sine square, simple sine square, and sine to the power 4 to about 6 to the power 6, and even to the power 8. We can use this method. Let's continue. So what do we have here so far? We got S4. So this integral equal to, the first term is SQ times C, we have 1, plus 3 times the first term is S squared. S squared can be written as I2. That's why I explained this is I2 here. A third term, be careful, a third term will be negative, okay? So you have times c. Sorry, you have times 3. But the third term will be simply can be written as the integral we are looking for. Can you see? This is a beautiful equation because that will, although we cannot solve the I4 so far, but we know that I4 is related to a known term and the simplified integration. Can we just rewrite this equation? So basically, we got the 4. If you move to, we got a 4. We move this part to the left-hand side. We got 4 times I4 equal to this 2 integral. And put this because positive. We put 3 times I2 minus SQ times C. And if you divide it by 4 on both sides, as you're dealing with any simple linear algebra equation, that is what we obtained. That's 3 I2 minus S3 times C. Remember, this is very important relation we're going to use later on because so far we haven't solved that problem yet, but it's getting there. Because from this equation we can see that if we just explain it a bit before we go further. So this question implies that if we can solve I2, so I2 is simple. We got I2 here, so we got to get, oh, say, actually this problem has been solved, you see. This is I2. So if you just plug I2 here, if you plug in I2 here, you get I4, okay? You get I4. So I4 solved. So that is a, so I think I don't have to go that far. So basically, if you plug I2, if you consider I2 is also the formula to be used, you can use, of course, you can use. Of course, during examination, you have to use a proper notation to simplify or speed up your derivation, okay, to save time, because it's important that you can reduce the time spent to dealing with each problem. Anyhow, so in this question, in this page, I have managed to solve the two integral sine x to the power of n when n equal to 2 and n equal to 4. Okay. After this preparation, it's time for us to dealing with this what we call a nasty, relatively speaking, nasty integral. It is that when the power is equal to 6, says here. So now it's time for us to deal with this integral. I6 equal to integral sine to the power of 6, okay, dx. Okay, because we have gained some experience by dealing with power 4, we know that in this case, we are obliged to use our heavy weapon, if not atomic bomb. We are going to use Canton called integration by part, IBP, integration by part. Okay, we'll use integration by part here. To expect, to hope that we can derive similar, it's called recurrence relation, can say, because it's kind of recurrence relation, so that we can deal with a higher n by using lower n. Okay, this just show how to do it. So in this case, we have first of all, we have dealing with how to because the objective is to reduce this n. So before I started the journey, before the journey start, I was talking about our objective is reduce this number. Okay. There are two ways can we reduce this number. One is that to rewrite this as 6 as a sum of 5 and 1, and put this sign behind the d. First strategy. So first one, how to replace before we use integration by part. So we have to do some house cleaner, housework, housekeeping. Let me see. We have tidy up. Right, we have tidy up. So what you can do, hang on. a bit, yeah, that's what we want. So before we go further, can we just do some simplification? Can we just rewrite it as sine? We borrowed one sine here, so it becomes sine to the power 5 and times sine x and dx. Okay, we're entitled to that because according to the index node, 1 plus 5 to 6. Now, more important is the agenda is that, see, I often have to remind you, so you have to make this, you can put this sign behind the d. How do we do that? We just follow the basic knowledge of the integration of the sine cosine. We know that if we put everything behind, we will end up with this one. So that is, use our notation now. So there will be the S5 times DC, you see. I have put the negative sign here. Do you know why? Yeah, if you still don't know, I just give the hint. So in our case, DC is equal to d cosine x. So therefore, we're equal to negative sine x and dx. Oh, almost. Okay. So that is reason why. That is reason. That's why I did so. Why I did so here. Now, in this way, we have seen that the number 6 is has been reduced to 5. That's good news. Because then, if we apply integration by parts, in principle, we should be, if we keep that s to the power 5 quintic term, right? There is opportunity that we can reduce it 5 further, which is 4, okay? We know 4, you see? So when you apply any method to solve the problem, you must have your strategy. It's just like play chess, okay? You must predict what is the consequence when you're doing so, what is the achievement, what is kind of the goal you can achieve. So our goal here is just reduce this number, okay? The higher the number n, the more difficult the integral would appear. And let's do it without speaking too much. Let's go do it. Now let's just apply integration by part. Now, just as usual, so therefore, we just continue this equation. So so that will give us I6. This is our problem of day. I6 can be rewritten as S5 DC. Okay, it's important now you have to consider what's to be U, what is to be V. So that is a 2 variable here. Because just recall, our objective is to reduce this number, the index. So we will choose this as U. This will be C will be a V. Okay. After the decision, and we can just use the integration by part formula that will equal to S5 times C, which is U times V. Do I have to write formula here? Perhaps. Yes, is that will equal to D. Now I just write the formula before we go further. So that's pretty same to this U times dV. Okay, that will equal to UV light. I just recall how to remember this order. UV light is harmful. UV light, ultraviolet violence is helpful for your health. So trying to reduce it all the time. So therefore, the sign here is negative. Can you remember now? UV is harmful. You're always trying to minimize. So therefore, you always don't use addition here. Okay, and that will become VDU. So that is the formula for integration by part. So let's just continue this writing. Can you see? This is UV. Take away integral here. What is a V? V is a C. Okay. What is DS5? DS5. So DS5 is composite function. Okay, we just go to the basic method to calculate differentiation. 5S4. Okay, 5 minus 1, and time S, time C, sorry. Times C here. C for cosine, cosine. So basically what this short notation represents sine x to the power 4 and time cosine x, okay? Okay, we just use this notation now. We just use 5. Okay, we probably can put 5 here directly. Put 5 here. We got s to the power 4 and c and dx. So the variable is dx. So in this way, we finish this VDU. Okay, with this VDU. Is it du? Yeah. Yeah. Okay, I can write it down. So these are du in question. These are du. Okay. So this is the explanation. Okay. Now, what can we do? We got c squared. We got we have opportunity to rewrite this one. Can we just to simplify this question? Can we just use another interval? Because I don't want. Or just before I go, I just make it more simplify a little bit before I go further. So that is 5, and that's c squared. Remember what is c squared? C squared equal to 1 minus s squared, according to Pythagoras Theorem. Pythagoras, the oldest mathematician. Okay, we know Pythagoras. Very useful, Pythagoras Theorem. Very useful. Then we got S4. So S4 to the power 4 here, and dx. Let's just continue, right? Without introducing new notation. So S5C minus 5. Now first one will be what? I just continue right to that one. First one will be S to the power 4 dx. Okay. The second one will be positive because negative times negative is positive. You still have to put 5 here in front. And look, the product of s squared times the s to the power 4 will be s6. What's that? S6. So this is exactly the integral we're looking for. So we can just rewrite the formula as, can we do something? So basically we got this s, we just copied again, s5c minus 5 times, now can we write this as our in our notation? That'd be our I sub 4. Okay. Don't get so excited because we know 4. I know it. I knew it. I know it. Wait a moment. Control yourself. And then we got, that is our 5. Don't forget about the factors. 5 times the integral we're looking for. You see, when you use integration by parts, you are entitled to discover, to explore whether there is an opportunity that you can show that unknown integral appear on the other side of equation. Because we were told at an early age, year 7 or even 6, the algebra equation allowed you to solve the unknown could be appear on both sides of equation. Okay. So therefore, we just cut the story short. Can we so therefore, we got this very important relation that can also be called a recurrence relation or recurrence formula, if you want to call it, when you're dealing with discrete, when you're dealing with discrete mathematics, like a series algebra, arithmetical, geometrical, even the Fibonacci, this series. So this is called recurrence formula. Can you see? Because we got the 6 on both sides, can we just mix them up? So we just do some house cleaning. So we put this, we cancel. This is 1 here, we got 1 here, we got 5 here, so this cancel. So we got 4 left. So 4I right on the other side. I just rewrite this equation. So that I6 will equal to, a bit crowded here. So this I6 will equal to 4x6 will equal to this side. I put this on the other side, so that becomes 5I4 minus, take away, S5 times C. So what is I6? Simple. So you divide it on both sides, by 4. That in that way, we can, hang on. So this is not 5, this is 4, okay. This is 4, this is 4. So in this way, we've got 5 times I4 minus S to to the power 5 times c divided by 4. Okay, so that is important achievement. We have, by the time you have solved this expression, you know, aha, I solved it. I solved the problem. Okay, you saw the light at the end of the other tunnel. You see, aha, like Plato. Aha, can see the real light coming from the 3D world instead of shadow or by the fire. You know. You study philosophy. Plato have the famous analogies that people who live in the cave. Okay, let's just return to the question. We'll talk about philosophy on the other occasion. Okay, we're not talking philosophy completely. Of course, mathematics is philosophy, the natural philosophy. Since Newton, that natural philosophy must be mathematical. Okay, there's no point to make argument by using just ordinary English or Chinese or French or Spanish or whatsoever. You have to use mathematics. Do you agree? So since Newton, if you are dealing with natural philosophy, not a psychological philosophy, not this political philosophy, it's nonsense. Okay. Well, if you are dealing with natural philosophy, you must use mathematical formulae. These are formulas. This is another. Can we just rewrite this before let's finish this talk soon? Otherwise, you have to wait to doing other thing. Shall we have a coffee break? Okay, great. Let's continue. Can we just rewrite this formula here? Because that's the most exciting moment now. So we just rewrite this formula here. We got I6, what we're looking for, equal to 5 times I4. So what is I4? If you can't remember, let's go back. What is I4? I4 is 3I2 minus S3C. Can you remember that? My memory is getting very bad now, so I have to copy that one. If you don't, you can, but unfortunately I can't hear you. So I4 will equal to 3I2 minus S3C divided by 4. And what's I2? I2 will equal to x half minus sine 2x divided by 4. Okay, got it. Let's go. Let's just substitute the formula now. We just sub formula. So what is I4? So I4 is 2 times something. I've used proper notation here. Can we just put the 4 here? I might put the 4 here. I got two term here. It's easier to handle. So this is a bracket. So I4 will equal to 3 times I2. Okay, I just don't jump too far. This is I2 minus SQC divided by 4. Divided by 4. First term. The second term will be, so negative, okay, negative 4. So that is the denominator is S5, s to the power 5 times C. Okay, what is I2? So we can put it as a 2, but it's 4 outside. That be the 5 divided by 16. What is the I2? We know I2, so I2 will equal to, do you remember I2? Yes, I can, because I wrote it down. Trick, I can't remember, but I can write it down. So therefore take a note. When you listen to lectures in universities, and take note. If you don't take note, and you waste your time, okay? You say, oh, I can record the whole session. You waste your time, okay? Take note whenever you listen to the lectures, or when you always take note when you're reading book. Take note when you solve the problem, okay? You don't repeat your neighbor because simply, I want to work too. You don't have to work very hard. Okay? You have to be smart. You have to be wise. Let's go. So this is I2. This is just I2 here. What is I2? I know that is x divided by 2 minus sine 2x divided by 4 is I2. Okay. Now, can we just rewrite all these short notes by the full name? Instead of use their initial, it's sine x times cosine x divided by 4. Got it? Anyway, we can simplify that. Yes, we can put the 2 here. So we're going to put 2 outside. And 2 self outside. That's therefore 0 equal to. So 3 times 5. All these 2 terms, all these 2 independent terms here, independent terms. So basically we got 15 divided by 32. Do you want to go that far? It's 32. We put the 2 outside. 32. That's 32. And then first term will be x minus sine 2x. We have to take 1, 2 outside, so there's only 2 left here. I think that is a simplest formula we can write. Sine x to the power 5 and the cosine x divided by 4. Don't forget, plot a constant, because some of the IB examiner are very unprofessional. I call it sick people. They just pick up this tiny mistake and take away of your mark or even 2. So be careful, be careful. And that is end. That is end. So you see, we can, perhaps I'll give you a 2-minute summary, okay, because it's a long talk. So basically, what I've done here, so our objective is to find the solution of this integral. And this integral can be subdivided into 2 categories. One, the n is an odd number. Another type is n is an odd number, such as 2, 4, 6, 8, 10, and so on. As you can show in page 1, that if n is odd number, the integration is relatively simpler or straightforward, much straightforward, can you see? And even if it looks higher, say for example, when looking at higher, you can see in this case, we still can manage that, because in that way, because it's an even number, we can always use the cosine as, you can borrow the cosine so that we can introduce the power form. So that's important thing the trick used to dealing with this integral when n is odd number. Eventually, you are actually looking for apply this basic formula. But when the n is even number, things can be getting very nasty. Well, not in the case of 2, okay? For if n is 2, we can still manage it by using our knowledge of trigonometry. So trigonometry function relations are essential when dealing with integration. So what is goal of why do we have to learn how to solve integration problem? It's just logical exercise that they just integral there, and if you can use some basic axioms or basic knowledges, you can rewrite the form. So the integration or differentiation can be considered as transformation. What is transformation? Transformation is just rewrite something, rewrite a mathematical expression in accordance with axiom, with the definition of this operation. So it's logical. So you don't have to, in the real life, you don't have to deal with integration, okay? Because every integration is digitized. It can be solved by numerical method, okay? Of course, to publish the paper, and in the long run, if you want to become a scientist, research scientist, then you have to know how to handle that, to manipulate the formula so that people, especially people outside your area, will think, oh, what marvelous work have you done. It's not marvelous. I mean, everything is, no matter how important, you have to pinpoint that the essence, the axiom. For example, what Einstein did in 1905 in his special relativity. Simple, C equal to constant. How about his general relativity? Simple, okay. The gravitation is due to the curvature of space. Let's not talk about that too fast. Just summarize this, what will happen. So that's how we do. So we managed to find the I4 first. It's take a longer time, but not very, very challenging. Okay. So just if you, of course, you have to get very familiar with integration by parts. Okay. That is our weapon, also as cannon. Yeah. So what is the atomic bomb in dealing with differential equation? How about hydrogen bomb? How about the neutron bomb equivalent in dealing with the calculus problem? Let's talk about next time. That is, this has been probably over half hours now, even 40 minutes. Let's go to next page. That is how we obtained this integration. Can you see? By use the integration by parts. Yes. And during which we can encounter that we have seen the first time, if it's the first night in the other end of tunnel, or outside the cave, or Plato's cave, we saw the sun shining from this first recurrence formula. Not the first recurrence, it's our final. Because you see this chain rule, is kind of chain rule. See, once you know the 6, and we know the I2, we can plug we can plug in. I like the word plug in. We can plug in so we can solve the problem. Okay, that's all for today. And thank you for your patience. I hope you have learned something in calculus.